Hi, great to see you, and very welcome to the course Fundamental X.509 PKI in Theory and OpenSSL. My name is Cyril Gössi. I'm a computer scientist from ETH Zurich. I work for a large multinational and globally operating company, and I'm a cryptography lecturer at a Swiss university. Now, this course is all about X.509 Public-Key Infrastructures, or X.509 PKIs in short. And these X.509 PKIs are authorities issuing X.509 certificates to end entities like an Alice and a Bob. With these certificates, the PKI assigns cryptographic public keys to the end entities, and it's then these public keys that can be used for various cryptographic purposes, such as providing confidentiality to data exchanged by means of encryption, or to provide authenticity to data by means of message authentication codes or cryptographic digital signatures. In order for these cryptographic applications to be secure, it's required that end entities making use of a certificate can trust that the public key contained in the certificate is really the public key corresponding to the private key owned by the peer that's intended to be communicated with. If, for example, Alice wants to encrypt data such that only Bob can retrieve it, Alice would have to encrypt the data based on the public key of Bob. The real challenge to solve is then for Alice to obtain an authentic copy of the public key of Bob, which she can get if Bob has his public key certified by a trusted PKI. If that's the case, Alice can take the certificate of Bob, verify it's a valid certificate issued by a PKI she trusts, and if so, take the public key contained in this certificate to ultimately encrypt the data for Bob. As we will see throughout the course, trust is a key concept in the world of X.509 PKIs, and trust is then also the key challenge for real-world X.509 PKIs to construct, such that end entities making use of certificates can really rely on these certificates to contain authentic copies of public keys of peers that they communicate with. What are the goals of this course? Goal number 1 of this course is that once you complete this course, you should have a solid theoretical understanding of the concept, architecture, and components of X.509 Public-Key Infrastructures. As I just mentioned before, trust is a key concept of X.509 PKIs, so goal number 2 of this course is that once you complete this course, you should have a good understanding of the trust model underlying X.509 PKIs. Goal number 3 of this course is then that once you complete this course, you should not just have a theoretical understanding of X.509 PKIs, but once you complete this course, you should also be able to apply your theoretical understanding of X.509 PKIs by being capable of constructing a two-tier X.509 PKI yourself, and to know how this X.509 PKI could be instrumented for various cryptographic purposes. In this course, the X.509 PKI is constructed with OpenSSL, which is one of the most popular and most widespread tools available, serving very well most of the use cases of X.509 PKIs and X.509 certificates. The last goal is a goal to me as the instructor of this course. My goal is that throughout the whole duration of this course, I will try to continuously animate you to stay engaged and to not always just simply present you with all the ideas straight ahead, but to provoke you with targeted questions with the aim to hopefully jointly develop many of the ideas and concepts that we will get to know throughout this course. In terms of actual content of this course, we will essentially go through 4 stages, and we will start with a chapter providing the essentials of cryptography just enough to later understand the key cryptographic mechanisms taking place within X.509 PKIs. For this, it will be essential to understand the concept of encryption to provide confidentiality to data, and it will be equally important, if not even more so, to understand the concept of digital signatures to provide non-repudiation to data, which is one of the strongest integrity-related security notions provided by cryptography. With these essentials of cryptography at hand, we will then go into a chapter providing the theoretical understanding of X.509 Public-Key Infrastructures, where we will get to see what the key purpose, concept and components of X.509 PKIs really are, and where we will get to know in-depth X.509 certificates and how these certificates are created and validated, and where we will get to know the trust model of PKIs and the implications this trust model has on the validation of certificates, which will ultimately have to be augmented to a validation semantics on chains of certificates. The theoretical investigation of the subject is then followed with 2 chapters dedicated to the application of the presented theory by first constructing from scratch with OpenSSL a 2-tier X.509 PKI that could essentially be used for any cryptographic purpose, and which in the last chapter of this course we will ultimately use to iteratively add security to an initially insecure email communication up to a point where we will have a system that can provide both confidentiality as well as non-repudiation to emails exchanged between, for example, an Alice and a Bob. To me, this sounds very cool, so let's get started with the course.